All right, so here we are in part 8. Time for some coding. First thing we need to do is fix up that spelling that I pointed out a few minutes ago. So Logan, let's go ahead and jump over into Visual Studio Express and hop over to the bars class for me real quick and go take a look at that enum at the top.
All right, let's scroll back up to the top of the class.
Here
we have the bar element. So let's swap the G and the N, so we now have bar alignment. As a matter of fact, hang on, let me undo that. Let me refactor it because it is used elsewhere. So I'll swap the N and the G, and then we replace the 2 additional places, bar alignment, and wherever else the other one was.
Perfect. Now, while we are in the enumeration, let's go ahead and remember we said that we were going to basically change right to a value of 2. So we can put it there for just a second. But by doing this, well, that's what we get by default if we don't go in there and explicitly set numbers for each of these guys. So we can just remove the 0, 1, and 2 and make it look a little nicer.
Right. Now, if you wanted to leave these here just for explicit reasons, since the values are in fact used, there would be no harm in doing that.
No, not at all.
But since it's the exact same values as will be assigned automatically, we'll just let that happen.
Okay, so now that we've got that in place, I guess it's time to go ahead and take a look at implementing some methods. So we were going to start out with our loop over in the draw bars method, where we're going to call on draw for each of our bars.
Okay, so let's scroll down to draw bars, and let's begin with that loop. This is going to be a simple for loop, so I'll grab the template for it. The length is going to be based on how many bars we have. So we want to look at bars.count for the number of things to loop through.
That's right.
Now, with each of those bars, now we're looking at the indices individually, we need to grab each bar out of that list and tell it to draw. So what we'll do is we'll take the bars list, sub I, and tell that element to draw. Now the sprite batch needs to be passed along to the draw call, so I'll plug in the sprite batch parameter and pass that on to draw.
Perfect.
And that's it.
Yeah, really simple. Now let's go ahead and implement draw, where things get a little more interesting.
Right, because there's a few things we need. The draw call is going to rely on an origin and a rectangle, a destination rectangle. So let's get those in place. First, let's look at the origin. The origin is going to be of type vector2, because that is what draw expects. I'm going to call this variable origin, and we'll set that to a number based on the alignment. So in order to get this vector2, I'm going to make a new vector2, and then we can address the x component. And the x component is going to be based on that alignment. So all we're really going to do here is take alignment and cast it to an integer.
Or a float. We'll just go straight to a float.
Oh, sorry, I was looking at something else. Good catch on that, though, because I was going to go to int, and then that would probably get implicitly cast the float, which would be less efficient. But remembering the alignment, which is an enum, so we have left holding a value of 0, center holding a value of 1, and right holding a value of 2. So all we do is we cast to float the alignment. Remember, alignment is a field of this bar, so we simply cast that to float.
Okay.
Now, as we talked about for y doesn't have an alignment. We're always going to do top align for all bars, which means we can hard-code in a value of 0.
Perfect.
And that's it. That takes care of our origin.
Okay. Now we need to go ahead and define that destination rectangle. So exactly how much are we going to stretch this little texture out to? And we'll do this by defining a rectangle here called bar rect.
All right, so put in bar rect, and then we need to make that rectangle. So new rectangle, and inside of this we're going to need to take into account first the position. So that would be the position x and y, both of those are floats, so they need to get cast to int in order to be stored in a rectangle. So an integer for the position y, so this dot position dot x, or excuse me, I said y, meaning x.
Oh, we all know what you meant.
And I'm going to drop down to new lines for each of these components, otherwise I'm going to use up all my screen space. Next we need to address y, and again I will cast that to an integer, so this dot position dot y. Now we need to look at the rectangle's width. And the width is going to be driven by the bar's percentage. So it already has a width value, but we need to multiply that by percent. And let me write this out before I cast it to int, because if we said this dot width is already an integer, so that looks fine. But multiplying it against the percent, or excuse me, not position, the percent is a float, so that would cause an error. We have to actually cast that over to float.
To an integer, yeah.
And the other thing is, looking at this, it will still give an error because it's casting this dot width. We need to cast the result of the entire expression, so I'm going to encase that in parentheses.
There you go.
And then we have everything set up. Now the last part of that, height, can be plugged in directly. Height is an integer, and can be stored directly in the rectangle.
Perfect.
So we'll end off the parenthesis, add a terminator, and that will take care of our destination bar rectangle.
All right, so now that we have that rectangle, we can turn around and we can use the fifth overload of the draw method from sprite batch to draw it.
All right, so let's plug that in. Sprite batch is given by the parameter, so we'll use it, and we'll call upon its draw method. Inside of draw, like you said, we're looking for the fifth overload, which takes in, beginning with a texture. That's going to use the static bar texture field. The destination rectangle we have defined as bar rect. The source rectangle will be null because we're going to use the entire source texture. The color is going to be given by the bar's color field, so we can use this.color. The rotation will be 0 because bars aren't going to be set up to use rotation. Origin has been defined in that origin variable we put together. The sprite effects will be none, as noted in the implementation plan, and the layer depth will be 0, as we are not using layers for sprite drawing.
Beautiful.
And that takes care of the call to draw.
That's right. So now we can go ahead and finish off our constructor.
All right, let me scroll up to the top. We began the constructor. We have the bar being added to the list, but nothing is being initialized.
Yeah, we basically have a width, height, and a color being sent into the constructor, but we're just dumping it. We're not using it. So let's go ahead and use it.
All right, let's save each of those into their relevant fields. Let's begin with width. So let's set this.width equal to width, this.height equal to height, this.color equal to color. Then we have two more. We need to initialize the percent, and we're going to say that bars upon creation start out at 100% or a percent value of 1. So this dot percent equal to 1. And then finally, let's initialize the alignment. Though in theory, it being an enum or a field of type enum should hold the first one, but I do like to explicitly initialize these here so it makes it obvious what's happening. So we're going to set the alignment. Let's default that to bar alignment left, so that all bars are left aligned unless otherwise specified.
All right, very nice. So that takes care of everything we needed to get in place inside of the bar class. So now what we need to do is go ahead and change our attention over to a new graphic that we need to get brought in so that we can then load that graphic over in the load graphics content. Let's go ahead and build just to make sure everything works well.
Right, let's build and see the result here.
Nice and happy.
So other than the unused texture, everything has succeeded.
So we're just about to run out of warnings. That's awesome.
So right, what we're actually about to do is we're going to jump into the game class and load a texture. We need to load that fill texture for the bars texture. We were originally going to use a 3 pixel by 3 pixel graphic as discussed in the implementation plan, but after taking a closer look, we discovered that 3 by 3 won't work for centering.
Right.
So what we have to replace that is a fill 22 graphic, 2 by 2 version. So I'm going to take that and put that in our project folder. So here's projects, here's a precision project, and of course it's textures folder. So let me paste that in, and let me swap it out inside of the solution. Let me go and add in that fill 22 texture. And dropping out of content pipeline files, there's fill 22. And I can completely remove fill 33 from the solution. So let me delete that out, and I will be just left with fill 22. Now that we have the proper fill texture, I can set up the bars texture.
We could also, real quick, just jump on back into the folder real quick and delete out, just to keep everything very clean.
I believe deleting it from the solution.
Oh, it sure did, yeah.
That's why I asked. There's in there saying, it's like, look, we're going to delete this file. Are you sure? Because I have been working directly inside of this. I haven't been getting textures elsewhere and letting Visual Studio place them here. I've been working in the actual textures folder.
Hey, I'm allowed my one brain knock against the desk per night.
Right, but your head was in a good place. You want to keep everything clean.
That's right.
It's just Visual Studio managed to get one step ahead of us.
Okay, so let's go ahead and load in that static texture.
Since most of this is going to be done in the same manner as the texture fields, I will take the liberty of doing a copy-paste duplication on one of these lines. Because again, we're loading that fill 22 graphic. But where we want to store it is now inside of the bar, or rather the bar's static texture field.
Okay.
So that's where this graphic will be held. So this takes care of the objective of loading in the static texture.
All right, so now let's go ahead and jump down to our draw method.
All right, we'll scroll down to our game's draw.
Okay, and we need to make our call to bar.drawBars.
And this goes back to that thing you were talking about of what order do we want the bars to draw in. Do we want bars to draw over actors like enemies, or do we want them to draw behind enemies?
Right.
And we want them to draw behind. because otherwise it would look funny since we have a display-like element overdrawing things. So what I'll do is I'll actually draw in the bars before actors. That means bars get laid down, and then actors get laid on top of them. So that way if an enemy crosses a bar, the enemy will overdraw it.
Okay.
So I'm going to drop down a comment as well, and apparently I've hit the caps lock key. We'll drop in a comment saying draw bars, which is a call to bar.drawBars, where we pass in the sprite batch. And it's as simple as that.
Okay. So that wraps up everything we needed to do inside of game. Now, at this point, are we good to go for creating a bar?
It would be a good idea. Let me build, make sure that there's no errors up to now.
Very nice. We've got rid of all of our warnings, too. So now let's just see if we can create, I mean, it's not going to be a bar that's going to update or anything, but it's not going to be
animated. But it would be good to verify that everything we've got in place is working. Maybe test some alignments, test some positioning.
I agree, before we jump over into cell.
All right, so like with everything else we've done as a test, let me jump to load graphics content, because this is going to require that bar texture before it will work. And now let me jump down and create the bar before I add any actors, because we just discussed about, well, I guess it wouldn't matter. It could even be added after since they're being handled differently. I'm going to jump down to the bottom just to prove that. Now let's make a bar as a test bar. What I'm going to do is make a bar variable here so we can turn around and set things like position and alignment. So I'm going to make this bar variable set to a new instance of bar. Bar is going to need to take in width, height, and color. So let's give this a width of maybe 200, maybe a height of about 10, and a color. Let's look through the colors. So it would be a nice bright color. Color dot light green. That'd be a nice bright color which should show up well.
Okay.
And already I think that should show up if we load now, and indeed it does. There is a bar being drawn at its default location of 0, 0. So now let's move that bar. Let's turn on and set the bar's position, excuse me, not percent, but position, to a vector of 200 by 200. And then we have a bar position more in the center of the screen.
Excellent.
So now let's test percent. Let's see what would happen if we were to lower the percentage of the bar, because if you remember, they default to 1 or 100%. So if we set the percent to something less than 1, like maybe 0.3, the bar is shrunk now.
Very nice.
Or we could just drop it all the way down to maybe 0.02, and we should have just a tiny little sliver.
Almost, yeah. Very nice.
Right under that one cell.
Okay.
So all of that's working.
So we noticed that, run it one more time and point this out. We notice where it is being anchored at. Show that right here, how we've got that little black circle. So we can show alignment real quick.
Right, noting that if you look at the bar, the little sliver of green is right next to a dark black, dash almost.
Yeah, exactly. I forgot. We can't see the mouse when we put the mouse over, but you guys can because of the recording software. But yeah, there's a little black oval sideways with a slight slant
right, probably around there.
Dot.
I have no idea what I'm pointing at. But yeah.
So now if we switch our alignment, we can see if we can start covering that up.
All right, so if we go down here and set our bars alignment to be, let's say, bar alignment. What was the one you wanted to try, right?
Let's do right. And change the, well, go ahead and do that, because you'll notice that black little oval thing's going to be a little less now. And it is indeed a little less. Very nice. And so now change that 0.2 to, yeah, and that's going to cover it up.
Well, and then a cell over here.
Of course.
Let me lower the number of cells or even take them out entirely.
And look at that. We're now covering up that little black oval. So we're now going to the left as the bar gets larger.
So now back up to 30%. We continue to extend off to the left or a full 100%. And now we've drawn the other way.
Excellent.
So now let's take this 100% width and adjust it to center. And now we move the background screen.
And you can see just up underneath, right close to the center, the bottom little piece of that little black oval speck.
But I mean, that looks like it's working. We've got percentage and alignment both tested.
Fantastic. So now that we've got all of this working, let's go ahead and remove this section of code out, since it's just test code, and implement bars in our cells class so that cells have bars.
All right, and let me also put in the cell creation, because we're going to need some cells in order to test that.
That we are. Okay, so over inside of our cell class, I had said that first thing we needed to do was get some fields in place. So let's go ahead and create the life bar height, the life bar color, and the actual life bar itself.
All right, so let me jump back up to the top of the cell class and add these fields. So we could say these are life bar fields.
Okay, that's interesting spelling.
Yeah, it's very awesome spelling. That is.
Leafy bars.
So life bar fields. All right. So we need, the first thing is a constant for the height, just some setting to have for the life bar height. Wow, I've gotten really good at spelling since all this. All right, constant integer life bar height, which we will set to a value of 8.
Okay.
Next, we need to have a color for these life bars. So I'm going to make a private field of type color, which I will call life bar color. And let's set that to a color of red. So life bars, or cell life bars, are red in color. Now, the last thing we need is the reference to a life bar itself. So another private field, which I'm going to type of bar, and we'll call this life bar.
So if you guys want to have some fun with it, because obviously we're not going to take life bar color and define it as a constant, do something like, if your health is at 100%, it's maybe bright green, and then if it drops down, it becomes yellow. Then as it's almost run out, it turns red. Make it look a little more interesting. Just thought I'd throw that out there when he was typing.
And while you're doing that, think back to one of the Bouncing X versions.
Oh, yeah.
Where we actually made a list of colors to interpolate over.
So you can
go back to that lesson and try to combine the two concepts.
There you go. Excellent, excellent. Okay, so now that we've got our 3 fields in place for the life bars, let's go ahead and make sure that life bars are getting created in the setAttacked method. All
right. So first thing to address is setAttacked, where we need to create a life bar, because this is the point in the cell's life where it suddenly needs a life bar. It's just been attacked. So what we're going to do is to make a new life bar. So this.lifeBar equals new bar, and we're going to need to take in a width. Now we're going to have life bars match the width of the cells. So that means we can plug in the cell's texture width for the width of the life bar. The height has been defined by that constant, life bar height, and the color was defined by the life bar color field. So that will take care of the creation of the life bar. But if you remember, a life bar by itself will be positioned
0,
at 0, 0. So we need to move this life bar so that it's offset and attached to its desired cell. So that means we need to set its position. So this.lifebar.position, not life bar color, but rather the life bar field position. And I knew I was going to hit that. Always do. Alright, position. We're going to set that to a new vector 2. And now for the X component, we want to move that to the left side of the cell. Now remember, the cell's position X is going to be at the center of the cell.
That's right.
So we need to offset to the left of that by the amount that's half the width or the origin.
Yeah, we'll need to subtract away half its width, which is basically the origin, because the origin represents half its width.
Exactly. So that means we want to take this dot position dot X, which is centered. So we want a left align, so that would be minus this dot origin dot Y. Right.
X.
Or excuse me, X. Yes. I had already thought it, or moved on to the next component. All right. Now we do need to address the Y position. So this dot position dot Y. So that starts out at centered. Now we need to move down or add on to Y.
Right.
The value of the origin Y. So this dot origin dot Y.
And then, just for me, do +1 at the end.
Plus 1 or 2.
Do 2 then. And all we're doing here, a magic number that we're throwing in real quick just to make me happy, all this is an offset from the bottom of the cell, just so that the life bar is not hugging the cell.
Right. There's an actual visible gap below the bottom of the cell texture and the position of the life bar
So
itself.
if you wanted to create a life bar offset constant, so it's not a magic number, feel free to do that. This is just something I'm throwing at Logan real quick just for demonstration purposes for you guys. That's all.
Right, just for quick aesthetic purposes.
Yep. But in reality, you'd want to have some sort of offset constant that you could go in and just tweak until you get exactly what you're looking for. All right, very nice. So with this, Logan, before we do anything else, like, make the life bar's life change, how about we just see if a cell that gets attacked gets a life bar?
Yeah, for sure. Let's test this incrementally so we can see if things are working.
So, life bar. Life bar.
Another one.
Woo! Excellent.
So, and noting that the life bars are being positioned correctly as well. They appear below the cell, a little bit offset because of that additional 2 pixels, and the width of the bar matches the cell.
That's perfect. So now we need to make sure that in update, the life bar gets taken care of.
Okay, so let's find the cells update, which I believe is a little bit up. Here's update. Now we want the life bar to decrease as the life percent is being decremented. So here's this line. Now, here's something really cool. Think about the units that percent is given in, 0 to 1. Think about the units that the life bar percentage, or the bar percentage is given in, 0 to 1. So couldn't we do this dot life bar dot percent equals this dot life percent directly?
Beautiful.
Got a float, or should it, yeah, float to a float.
So let's test it out. And, hey, look at that.
Now we have the animated life bar for each individual cell.
Oh, that's fantastic stuff.
All
awesome. Right. Okay, so we now have that.
Here, let me restart and show the problem if I can find. Actually, let me restart the whole game because there's so many enemies. Watch this, though. If I manage to save a cell, watch what happens to the bars. They're all remaining after I save them. They are technically remaining after they reach 0. It's just at a width of 0.
Well, you can demonstrate that real quick. Just add a little bit extra on right there.
Yeah, we could always, let's do an offset. So the bars percentage is always higher than its actual life. So we could do something like 0.03f. Extra 30% just for visibility's sake.
So this will just demonstrate that
the life bars are remaining. So whether I save the cell or not, we always have life bars left over.
So we need to make sure that we remove these out.
All right,
let's go ahead and take that plus 0.3 out. Okay, let's leave it, just so that they can see that they are indeed disappearing. Okay, that's a good idea. So now we need to make sure that we remove out life bars when we are saved or dead.
Okay.
So let's jump down to the save method for starters.
All right, here we go with save. And this is indeed where we're saving a cell, so we need to make sure that its life bar gets completely removed. So what we're going to do is first take the life bar out of the list.
Okay.
Because we have the bar.bars list. So let's tell that list to remove one of the bars. And the item that we want to remove is this dot life bar.
Okay. But now we're still holding a reference to that guy, because life bar inside of this particular cell is still pointing to a life bar.
Right, so we still have a reference. So we want to make sure we break that reference, which we can do by saying this dot life bar equals null.
Perfect. So now if you test it real quick, if you save any, they're going to disappear, or they better. Ooh, sweet.
So very nice. Now, of course, if they die, they're still left alone, and that's where we're saying we need to address this in a dead cell as well. As soon as the cell dies, the bar needs to be removed. And it's actually the same 2 lines of code, so I'm going to copy both of these. And then let's find the cell death, which is back inside of update. As soon as we cross the threshold below 0, now we've killed everything, spawned an enemy, so let's jump down and also clean up the bar.
So now you'll see, basically, it's just going to go down and snap off. Pink.
And disappear. That's why we left the offset in place, so you can see the bar actually disappear, since it would go invisible anyway because of reaching 0%. But since we verified that bars are disappearing both on save and automatically, then we're good. We can go back to setting the percentage properly without this offset, and we know that behind the scenes everything is working correctly.
Exactly.
So let's test, and there's one life bar, visibly disappears, goes away. If I save some of these cells, the bars also disappear the moment they are saved. So, there we go.
Perfect. And Logan, that wraps up everything we had set out as an objective for Part 8, getting life bars fully implemented. So with that, that is going to wrap up this video. Thanks a lot, guys.